Welcome to this explainer. Okay, listen closely because we are operating under serious deadline pressure today. I want you to literally imagine this right now. You are sitting in the exam hall. The invigilator has called time, the clock is ticking down, the pressure is immense, and you turn the page only to see a massive, high-mark extended response question staring right back at you. The topic? Energy resources. Now, it genuinely doesn't matter if you are sitting the Cambridge syllabus 0625, 0651, 0652, 5054, or even 9702. I can tell you right now, with absolute certainty, this is one of the most chronically misunderstood areas in the entire physics curriculum. And honestly, it seems so easy at first glance, right? You just memorize a couple of fuels, you write them down, and you're good to go. Wrong. Absolutely wrong. Every single year, we see students get completely obliterated on these exact questions. But today, we are going to fix that. We are getting a rare, exclusive look right behind the examiner's curtain. We are going to treat this exact scenario like a high-stakes, breaking news story. We have to deconstruct the complex story, which is the question, and deliver the headline, the precise answer the examiner is desperately looking for. To show you what I mean, let me introduce you to two archetypal students I see all the time in my classes. First, we have Alex. Now, Alex works hard, but Alex overloads his answers with raw, unfiltered physics facts. He'll write an entire page on the microscopic details of how electromagnetic induction works inside a wind turbine, completely missing the fact that the command word in the question specifically asked for an environmental evaluation. Then we have Sam. Sam rushes. Sam is constantly watching the clock. Sam sees the word nuclear and immediately starts bullet pointing basic facts, completely ignoring the specific requirements of the prompt. Both Alex and Sam are leaving massive, easy marks on the table. Today, we are going to completely transform that approach. So that brings us to the crucial question you see right here. Why is this specific topic so deeply misunderstood? Why do both Alex and Sam fail to secure those top-tier grades despite clearly knowing the basic definitions? Well, the core problem is that students treat this chapter like a geography trivia quiz. They don't treat it like a rigorous physics application. They constantly struggle to distinguish between absolutely vital terminology. For example, they confuse the term renewable with clean, or they mix up reliable with high energy density. And here's the secret. Examiners are not looking for a simple list of memorized facts. They are actively looking for your ability to apply the correct analytical framework to a totally unfamiliar scenario. When you put Alex and Sam's flawed answers side by side with the examiner's red pen marks, a pattern emerges. You quickly realize it is almost never a lack of baseline knowledge. It is entirely a lack of strategy. And that is exactly why we are opening up the examiner's playbook in this session. Here is our roadmap for exactly how we are going to break this down. We're starting with the core principles, then moving systematically into categorizing resources. From there, we are going to hit the exact techniques you need to survive, the method mark strategy, and critical analysis. Finally, we'll reveal the top examiner traps and an incredibly powerful memory hack to lock all of this in your brain for good. We are covering everything from the foundational theory right up to the critical examiner warnings. Now, before we continue, subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into it. Let's move directly into Section 1, Core Principles. We need to see exactly how this foundation is built. Now, what is really fascinating here is the absolute emphasis the examiners place on foundation. Top-performing candidates simply do not just memorize isolated, disconnected facts about fossil fuels or solar panels. That is the Alex approach, and as we established, it fails under pressure. Instead, take a look at this direct quote from the Cambridge Principal Examiner Report. It brilliantly illustrates what they actually want. They want candidates to build a connected, conceptual understanding transferable to unfamiliar contexts. I want you to read that phrase carefully. Transferable to unfamiliar contexts. That's the secret sauce. The assessment objectives for Cambridge Physics target very distinct cognitive domains. Yes, of course, you need knowledge and understanding. That is your baseline ticket to enter the room. But the real marks, the ones that catapult you into the highest grade boundaries, come entirely from application and analysis. You have to understand the deep causal relationships. Why exactly does the insanely high energy density of uranium necessitate such a specific, complex type of reactor containment? How exactly does the intermittent, unpredictable nature of wind energy impact the baseload power supply of an entire national grid? When the exam throws a curveball and presents you with a completely fictional island nation and asks you to decide between a tidal barrage and a geothermal plant, you cannot rely on rote memorization. You must rely on the theoretical architecture of energy resources. And that rests entirely on precise definitions and integrating this topic with other syllabus areas. For example, you need to be able to link the efficiency of a power station back to the thermal physics chapter, or link the transmission of that generated power to step-up transformers in the electricity chapter. Examiners explicitly state year after year that candidates who reference these cross-topic connections achieve significantly higher marks. But how do you structure this? Before you even think about writing a single word, you have to decode the command word. Is the examiner asking you to state, describe, explain, or evaluate? To do this systematically, we use the PEAL framework. That stands for P for point, E for evidence, E for explanation, and L for link. Top students structure their physics answers by making a clear, definitive point, backing it up with hard physics evidence or data directly from the prompt, explaining the physical mechanism at play, and finally, linking it all back to the specific context of the question. Moving right along to our second section, categorizing resources. This is where we lay down the actual, tangible physics content. Because honestly, to apply that PEAL framework effectively, you need a flawless, rock-solid grasp of the types of energy resources we have, how they operate physically, and critically, how they stack up against one another. Okay, I want you to really lock your focus onto this table. Take a mental screenshot. This is your master cheat sheet for the exam. Let's break this down thoroughly, because knowing these specific advantages and disadvantages is the absolute bedrock for tackling those tricky application questions. First up, fossil fuels. We know they are non-renewable, but their primary advantage purely in physics terms is their incredibly high energy density. A very small mass of coal or oil releases a truly massive amount of thermal energy during combustion. It's concentrated power. But the glaring disadvantage, of course, is the massive carbon emissions and greenhouse gases they pump into the atmosphere. Next, we look at biofuels. Now, these are classified as renewable because, simply put, we can always grow more crops. Their unique advantage is their carbon-neutral potential. The idea is that the carbon dioxide they release when burned is theoretically offset by the carbon dioxide those plants absorbed from the atmosphere while they were growing. Sounds great, right? However, the massive disadvantage is land use conflict. Are you going to use that prime agricultural land to grow fuel to burn or to grow food to feed people? It's a massive socioeconomic issue. Then we have water, encompassing hydroelectric, wave, and tidal power. These are renewable. Hydro and tidal systems are incredibly reliable, which is a huge advantage over wind or solar, and they produce zero running emissions. The physics here is beautiful. It relies on converting gravitational potential energy or kinetic energy directly into electrical energy via turbines. But the catch, they come with a staggeringly high initial capital cost and massive habitat impact. If you build a hydro dam, you are flooding an entire valley and destroying the local ecosystem. Geothermal is fascinating. It's renewable, drawing immense thermal energy directly from the Earth's crust. Its biggest advantage by far is providing a consistent base load. It runs 24/7, rain or shine. But it is highly location-specific. You really need tectonic activity near the surface, like in Iceland, for it to be economically viable. Nuclear power. It's non-renewable as the Earth's supply of uranium is finite. The advantage? A truly massive energy output per kilogram. The energy density is millions of times greater than fossil fuels. You get a vast amount of power from a tiny amount of mass. The crippling disadvantage, however, is the radioactive waste, which requires incredibly complex, expensive, and long-term containment strategies because of its extremely long half-life. Finally, solar and wind. Both are renewable champions. Solar cells, or photovoltaics, convert light directly into electricity, while solar panels use thermal energy to heat water. Wind turbines convert the kinetic energy of moving air. Both have zero running emissions and are incredibly clean, but their shared, absolutely critical disadvantage is that they are intermittent. The sun doesn't shine at night, and the wind doesn't always blow. They are fundamentally weather-dependent, which means to use them for baseload power, you require massive, expensive energy storage solutions, like grid-scale batteries. Let's step straight into Section 3, the method mark strategy. This is where we shift from merely what you know to exactly how you show it on the paper, to legally steal marks from the examiner. In Cambridge physics, you have to realize that marks are very often awarded for the systematic process itself, not just for magically having the final correct answer. If you make a silly math error in step 1, but your logical physics process is absolutely flawless for steps 2, 3, and 4, the examiner applies a rule called error carried forward. They will actually award you those method marks. But, and this is a huge but, you only get them if you show your process clearly and systematically. Here is the exact standardized 5-step sequence required by examiners to process these complex energy problems. Step 1, identify the key elements and deconstruct the question. You must underline the command words. Are they asking for an environmental impact or an economic one? Step 2, extract the relevant data. Pull the numbers and conditions out of the dense paragraph and list them clearly. Step 3, select the analytical framework. This is exactly where you apply the PEAL structure we discussed earlier. Step 4, execute the analysis with crystal clear notation. Step 5, verify your results and present them in the correct format with the appropriate units. Think back to Alex and Sam from the beginning. We are now going to watch their red pen marks magically transform into green check marks. Imagine Alex rewriting his answer, but this time he's using the Peel framework. Instead of a massive, unorganized brain dump, he makes his point. Wind power is unsuitable for baseload. Then his evidence. Data from the graph shows wind speed fluctuates daily. Then his explanation. Therefore, the kinetic energy input to the turbine is highly inconsistent. And finally, the link. This makes wind entirely unreliable as the sole energy resource for the critical hospital mentioned in the prompt. Boom. Perfect execution, full marks awarded.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's dive right into our interactive workshop. Section 4, Critical Analysis. This is the exact moment where we separate the average test takers from the elite, top-scoring candidates. I want you to look closely at the basic problem solving on the left side of your screen versus the evaluative thinking on the right. If a question gives you a solar farm's energy output graph, basic thinking just looks at it and states solar power goes up during the day. That's descriptive. Evaluative thinking, however, aggressively questions the assumptions. It says, yes, peak solar output is at solar noon, but peak electrical demand for the city is at 6 p.m. when people get home. Therefore, this system requires massive battery storage to be viable. That is the stark difference you see on this slide. Let's do a quick challenge. Challenge 1, scan the data in your mind. And challenge 2, find the flaw. I'm going to give you a statement, and I want you to spot why it loses marks. The town should build a hydroelectric dam because water is a renewable resource and will provide infinite energy without any environmental problems. Did you catch it? Where is the flaw? It's that absolute sweeping statement at the end, without any environmental problems. As we just learned from our master resource table, flooding a valley to build that dam destroys local habitats and alters ecosystems. Evaluative thinking requires you to actively identify the limitations and drawbacks in your own recommendations. To truly master this section, you must constantly run this deconstruct, solve, evaluate loop in your head. Identify the given information, break the problem into highly logical steps, solve it systematically, check your answer for reasonableness. Look, if your calculation suggests a single standard solar panel can power an entire metropolitan city, you've obviously dropped a decimal point somewhere. Catch it before the examiner does. And finally, make strictly justified recommendations. Let's do challenge 3 right now. Speed writing. I'm putting 30 seconds on the clock in our minds. If I asked you to mentally construct a perfect Peel paragraph evaluating nuclear power, what exactly would it look like? It should look precisely like this. Point. Nuclear power provides a massive, reliable baseload. Evidence. This is due to the incredibly high energy density of uranium. Explanation. A single reactor can meet the city's continuous 24/7 power demand without emitting greenhouse gases during operation. Link. However, the staggering initial capital cost and the long-term radioactive waste management must be heavily justified against the strict economic budget provided in the town's prompt. If you can train yourself to think and write like that, you are literally thinking exactly like a principal examiner.
Now, please pay very close attention to this next part because this section is pure gold. Section 5, Top Examiner Traps. We are diving into the most valuable part of this entire explainer. Trap number 1. Consider this a massive examiner alert. The official reports reveal year after year that candidates consistently confuse key terminology. When you write an extended response, you must always define your technical terms before using them to draw your grand conclusion. Think about it. If you say a resource is efficient, what do you actually mean? Do you mean it has a high useful energy output compared to its total energy input, or are you just using it colloquially to say it's good? In physics, efficiency is a strict mathematical ratio. If you use it loosely like everyday slang, you lose the marks immediately. Similarly, if you use the word renewable, take 5 seconds to briefly define it in your context. State that the resource is replenished at the same rate it is being used. Precision in your terminology is absolutely non-negotiable. And here are the other top mistakes that will completely tank your grade if you aren't careful. Number 1, using the wrong approach for the wrong context. If the examiner's question specifically asks about the social impact of building a massive wind farm near a town, writing a brilliant paragraph about the mechanical efficiency of the turbine generator is the entirely wrong approach. You get 0 marks because you failed to decode the prompt. Number 2, forgetting to check format and presentation. Did you include your specific units? Did you leave your final answer rounded to the correct number of significant figures?
These are the easiest method marks to get and the easiest to throw away. Number 3, answers are not specific to the context given. This is the biggest one. If the examiner explicitly specifies a remote desert location entirely landlocked and far from the sea, and your grand recommendation is to install tidal power or a hydroelectric dam, you are showing the examiner you aren't paying attention. Your answer must be flawlessly tailored to the specific geographical, social, or economic constraints provided in the text. To overcome all these traps, you need to rely on our 3 rules that guarantee top marks. First, command word decoding. You need to know exactly what evaluate means versus describe. Second, Peel framework application to rigidly structure your logic. And third, the time management matrix. Allocate your time strictly based on the number of marks a question is worth. Never, ever spend 10 minutes writing an essay for a 2-mark recall question.
So, with all of this, how do we actually encode this mountain of information, the resources, the specific Peel framework, the examiner traps, so that it doesn't just instantly evaporate under the intense deadline pressure of the exam hall? We move to our final strategy in Section 6, the memory hack. I want to introduce you to something called the visual story method. This is a proven cognitive technique used to encode and rapidly recall the various advantages and disadvantages of energy resources by linking them into a highly memorable, deeply connected visual narrative. You see, our brains are hardwired to remember crazy stories, not boring black and white bullet point lists. So instead of trying to brute force memorize that giant table from earlier by rote repetition, I want you to build a bizarre, hyper-vivid mental movie right now. Imagine you are standing barefoot on a massive, boiling hot, steaming rock. That's geothermal. It's incredibly consistent and hot, giving base load, but you can't easily move it. It's location-specific. Suddenly, looking up, a giant, glowing neon green sun rises over the horizon. It's so intense and powerful it almost hurts your eyes. That's nuclear. It represents massive energy output, but it's glowing green, leaving behind dangerous radioactive waste. Now, this green sun shines down on a huge river dam, but the dam isn't made of concrete. It's made entirely out of giant corn stalks. That represents biofuels. They are carbon-neutral crops, but wait, they are taking up all the space where the water should be, instantly reminding you of the critical land-use conflict. Then a sudden, violent gust of wind blows all the corn stalks away, but just as quickly, the wind completely stops and everything goes pitch dark, reminding you immediately that wind and solar are wonderfully clean, but fatally intermittent. By linking these abstract, dry concepts into a single, absurd narrative sequence, you create an unbreakable chain of recall. During the actual exam, you just sit back, replay that crazy movie in your head, and all the required advantages and disadvantages will naturally flow right out of your memory and onto the page.
Which brings us perfectly to our final provocative question for this session. How will you apply this connected understanding to your next unfamiliar past paper context? You now hold the examiner's playbook in your hands. You know exactly how to categorize the resources, you know how to deploy the Peel framework to relentlessly secure those method marks, and you know how to avoid the specific, devastating traps that trip up unprepared candidates like Alex and Sam every single year. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.